Okay, our next part for 4.2, we're going to do quadratic modeling and regressions. So some of these, they're going to give you an equation. And this equation might be talking about height and might also be talking about distance or the number of employees or the number of trees or the numbers of products consumed. It can be talking about anything. We are going to approach those questions the same way when they give us an equation. So for this one, it says that Jimmy throws a rock off a cliff. Its height, h, over time, t, in seconds, is expressed by the equation following. And I also have a typo here. This one should be negative 5t squared. So if you could add a squared there, that'd be awesome. The first question is how long till the rock reaches its maximum height? So for these, I'm just going to draw a sketch over here. So we are throwing a ball off a cliff and then it's going down. Its maximum height with time on the bottom, that is our vertex. So the amount of time that it takes to get there is going to be the x value of our vertex, which is found by negative b over 2a. So how long till it reaches its maximum height? We are going to figure that out. So b is 40, so we'll do negative 40 over 2 times our a value of negative 5. Now it is really important that you simplify the bottom first before you type it in your calculator. So this becomes negative 40 over negative 10, which simplifies, to 4 seconds. Now, if you were to type in negative 40 divided by 2 parentheses negative 5, you will see that you get 100. The reason is because your calculator is doing negative 40 divided by 2, which is negative 20, and then they're multiplying by negative 5. So unless you type it in with double parentheses, you will get the wrong answer. So it's easier if you just simplify the bottom and then do your division on the calculator. Okay, so our next question, what is the maximum height reached? So we found the x value of our vertex. That gave us the time. The y value over here is then going to be our maximum height. So in order to get that y value, we take the x and we plug it into our equation, or in this case, t. So instead of that t, we're going to plug in 4 because we know it takes 4 seconds to get to that height. And this you can just type into your calculator. Oh, that should be a 4, to get your answer. And again, you want to type it in the way it looks. So we have negative 5 times 4 in parentheses squared plus 40 times 4 plus 24. And that gives us 104. And I believe this one, I don't think it tells us. So we'll just put units. So when it asks how long or how many till it gets its maximum or its minimum, you are going to use negative b over 2a. Then when it asks what is the maximum or the minimum, you plug in your x value to get that answer. The next one, what is the height at 7 seconds? So again, we're just going to use our general equation, and instead of t, we're going to plug in 7. Okay, and I'm just going to copy this equation and swap out the 4s with 7s. There we go. Oops, wrong one. Doesn't work if I type it in wrong. There we go. And this time we get 59. And it makes sense that even though it was longer, that this height is smaller, because in answer B, that was our maximum height. So we shouldn't get anything higher than that maximum, because after it reaches its maximum, it starts going back down closer to the ground. All right, there was example 1. Our next one is going to be velocity word problems. So the standard setup for a velocity word problem is going to be negative 16t squared plus your velocity times t plus your initial height. So VO, that is your initial velocity. if it is an upward velocity, you are going to add it. If it is down, you are going to subtract. So v is positive if it's upward, negative if it's down. And then this h at the end, ho, that is your initial height. So that's the height it's telling you you are starting at. And if it doesn't mention anything about like your initial velocity or initial height, that is just going to be 0. So if they tell you nothing about it, you are going to assume it's 0. And then this h is your height at t seconds. So to get that, you plug in a number for t, and then it gives you your height at that time. Okay. So if we look at example 2, you drop a penny off a 100-foot tall building. So in this problem, we know we're dropping or tossing something, so we're going to use our velocity equation. They did not tell us anything about our velocity, so that's going to be 0. And then our height, it was off of a 100-foot building, so that means our initial height is 100. So then we can write our equation, and for it to be an equation, you have to have an equal sign. So we'll have h equals negative 16t squared. That's how all of these problems are going to start. Plus 0t, and then plus 100. Because 0 times anything is 0, we don't have to write this part down. If you do, that's okay. But it's going to probably be easier for you to work on solving if you don't. So you would have negative 16t squared plus 100 for your final equation. Now, using that equation, how long till the penny hits the ground? So if it's at the ground, that means its height after that much time is going to be 0. So we're going to plug 0 in for the ending height or the resulting height. And then we're going to solve for t. So there's only a t squared, so I can solve just using inverse operations. So I'm going to subtract 100 on both sides, and that gives us negative 100 equals negative 16t squared. Now, I don't want to get imaginary numbers, and if I were to take the square root right now, I would get imaginary numbers. So I want to divide by negative 16 first. So if I take 100... Oh, my calculator stopped working. Here we go. So if I take 100 divided by 16, that gives me 6.25. And if you get decimals, that is okay. That will happen. And if you need to round this final answer, that's all right as well. Because it is a word problem, that is okay. So we will do the square root of 6.25, and that gives us 2.5 seconds. Now, normally when you take the square root, you get a positive and a negative answer, but it doesn't make sense to have negative 2.5 seconds, so for this one, we only need the positive answer. Okay, our next question is very similar. It says an egg is thrown with a downward velocity, so that means we have a negative velocity of 4 feet per second from 5 feet above a building. 382 feet tall. So we had a building. This one was 382 feet, and we threw it from 5 feet above it. So that total height is going to be 387. That is our starting height. And we said it had a downward velocity of 4, so that is our initial velocity. So now we can write a quadratic equation to model this situation. So again, it always starts with h equals negative 16t squared, and then a downward velocity, so we'll have minus 4t, and then a starting height of 387. That's our answer. So it's just asking for the equation there, so we are good. Then, when will the rock reach a height of 150 feet? Before, when we were asked when will it hit the ground, we knew that that height result was 0. Now we want to know when it hits 150 feet. So we plug in 150 for our h value, and the rest of the equation stays the same. Now we have an equation we can solve for t. Because we have a t squared and a t, solving using inverse operations probably not going to work. So we are going to use quadratic formula. In order to do that, one side has to equal 0. So we're going to subtract that 150 on both sides. So we have 387 minus 150, and that gives us 237. Now we're going to use quadratic formula. So that time is going to be negative b, so 4 plus or minus the square root of negative 4 squared minus 4 times a times c, all over 2 times a. Okay, so I'm going to figure out what's under that square root first. So we have negative 4 squared. Remember, that squared has to go outside the parentheses. And then minus 4 times negative 16 times 237. So we will have 4 plus or minus the square root of 15,184 all over negative 32. Now, when you type this into your calculator, and you can write it over on any empty space if you have some over there, you are going to type it in once where you add the square root and once where you subtract the square root. So let's do the adding first. We'll do 4 plus the square root of 15,184 and then hit enter. And that number is going to be divided by negative 32. So that gives us t equals negative 3.98. Okay, and that's a negative number. We don't want negative numbers for time. So now we're going to do the exact same thing except subtract the square root. So we have 4 minus the square root of 15,184 divided by negative 32. This one gives us t equals about 3.73 seconds. This is a positive number, so that is the answer we are looking for. All right, and that is how you would do a problem where they don't give you an equation and you have to write one for velocity. And then also how you would do a word problem where they do give you an equation. And these ones, again, are not always going to be about height. So if it gives you a different type of problem, it's still talking about the same thing.